Hello everyone, this is Brianne Pernick and we are now going to resume Chapter 1, Lesson 4 for Robert Morris University Math 0900. We just finished with the examples of talking about how negative bases have to be written with parentheses because it does not mean the same thing without it. We are now going to talk about the rule for the sign of exponents. Now what I would like to point out here is that if we just quickly read this little box, it says that when a number is written in exponential form and the base is negative, the result will be positive if the exponent is even. The result will be negative if the exponent is odd. Have we heard this before? Think back to the lesson on multiplying and dividing of real numbers. There was a trick that I taught you that dealt with positive and negative signs. We learned that whenever you had the repeated multiplication and the number of negatives was even, the result would be positive. We learned that if the number of negative signs was odd, the result would be negative. Being that an exponent represents repeated multiplication of the base, this concept should make sense to us because the exponent is telling us how many times to multiply that base by itself. So when we have a negative base, we can use that same little trick to determine whether or not our answer will be positive or negative, and then we won't even have to think about that negative sign again. Looking at letter A, we have -4 raised to the second power. Since the base is negative and the exponent is even, that tells us that our answer is going to be positive. We don't even care about that negative anymore. 4 to the second power is 16. Now, letter B, pay close attention. We have -4 squared. They look similar. However, the base is just simply 4, which is positive. This rule only works for the negative bases. So for this one, we're going to evaluate that power. 4 squared is 16, but we have to bring that negative down front. For example, C. Look at your base. Is your base positive or negative? Be careful. There's no parentheses. So your base is just a +1. So we're going to evaluate 1 to the 10th power, which is 1, and bring down that negative in the front. And then lastly, we have example D. Well, not lastly, but in this row, we have example D. We can now use this rule. We have -1 all being raised to the 10th power. Since 10 is even, we know that our answer is going to be +1. Letter E, we have -3 raised to the 3rd power. Since the power is odd, we know that our answer will be negative. So you just have to focus on doing 3 to the 3rd power, which is 3 times 3 times 3, 27. And then lastly, we have -3 all raised to the 2nd power because of that parenthesis. When the power is even, you know that your answer will be positive, so we just have to do 3 squared, which is 9. We're now just going to look at some more examples. I just want to show you some variations of exponents. These ones are just a little bit different because they contain fractions and decimals. So in letter A, when you are raising a fraction to a power, and you will note that the entire fraction is the base, and we know that because of the parentheses there, that exponent is actually going to go to the numerator as well as the denominator. So we can turn that into 1 cubed and 3 cubed. And then from here, we can just simplify this fraction by taking care of the math. 1 cubed is 1, 3 cubed is 27. Now, when you have a decimal cubed, you just simply can plug that right on into your calculator and let that do the math for you. Just be very careful that you are copying down the correct answer. We do get 0.0081. Now we have another fraction here. Why don't you guys go ahead and do this one on your own? Pause the recording, take care of the problem, and then resume as soon as you're ready. Okay, by now everybody should have had an opportunity to do example C. This is an example where we have an entire fraction as a base. So we're going to go ahead and make this 3 to the 4th power and 2 to the 4th power. And then we can do the math for each part of that fraction. 3 to the 4th power makes 81. 2 to the 4th power makes 16. You can check to see if you can reduce by anything to make the fraction smaller. You can't in this situation. So you would just want to go ahead and turn that into a mixed number. If you're still having trouble with that, just remember you're going to set up a little bit of a division problem there, and it does end up going in 5 and 1/16 times. Letter D. Now, if you take a look at letter D, you will notice that we have two different bases. Since you have two different bases, you do need to treat those like two different problems. So the first thing that you're going to do is say, well, we have 3 to the 4th power being multiplied by 4 squared. So we're going to go ahead and take care of 3 to the 4th power first, which is 81. And then we'll multiply that by 4 squared, which is 16. So now we have 81 times 16. When you do that math, you get 1,296. Letter E, we need to solve this one very, very similar to how we did letter D. The reason being is that we have two different bases. Why don't you go ahead and pause this recording, solve letter E on your own, and as soon as you're finished, you can check your work. Okay, at this point, everybody should have solved this problem on your own, and at this point, we're just going to check our work together. We should have evaluated 2 cubed, which is 8, minus 3 to the 4th power, which is 81. When we subtract 8 minus 81, that falls back on those rules I taught you guys. Whenever your signs are different, we are supposed to subtract. So 81 minus 8 gets us to 73. Which number had the bigger absolute value? It was 81, so we're going to keep its sign. Our answer is negative 73. At this point, we have completed Chapter 1, Lesson 4. Please let me know if you have any questions whatsoever, and I will be more than happy to work with you and resolve those issues. Thank you for watching this lesson.